In this lesson, we will learn how to program our Arduino. Also, we will learn some basic concepts in programming in general. The Arduino programming language is merely a set of C and C++ functions that can be called from our code. Our Arduino code is usually called Sketch. So let's proceed first to learning some concepts in C and C++ programming language. C is a general-purpose procedural programming language originally developed in 1972 by AT&T Labs. C++ was later on derived from C, which is an improvement of C. And C++ is already an object-oriented language. Why do we use C and C++? Because it runs a fast code. If we are programming an embedded system or the Arduino, we have limited resources, like we have small memory, small computing power, small power requirements. Therefore, we need a fast language that can implement our codes. And C and C++ does it better than other higher level languages. Arduino code compilation. What does it mean when we compile our Arduino code or sketch? It means that the compiler is translating our human-readable codes into binary or machine code because Arduino can only read binary machine code. Upload. What does code uploading means? It means that the binary files that have been translated by the compiler will be uploaded or transferred into the Arduino. And then our code or binary files is already residing in the Arduino. It can run without connecting your computer. I have here a sample C program structure. First part, number include stdio.h. If you see a number sign or hashtag symbol in front of the line, it is a preprocessor. What it does is that the compiler executes this line first before compiling the whole code. For this specific number include statement, it will include stdio.h header file during compilation. Next part, int main, open parenthesis, close parenthesis. This is an example of a function. A function can contain one or more statements inside of it. The function starts with an open curly brace and ends with a close curly brace. This line is a comment. You see there's a slash asterisk at the start and asterisk slash at the end of the line. Printf hello world is a statement or expression. We usually terminate a statement with a semicolon. Return 0 semicolon is again another statement or expression. Let's discuss some C program syntax. As I've said before, a semicolon is used as a statement terminator. Please don't forget this because your sketch will get an error if you forget a semicolon. How do we use comments in C or Arduino? For single line comment, we use double slash. It will then comment out the whole line. For multiple line comments, we start with slash asterisk and asterisk slash at the end. What are identifiers? They are names used to identify a variable, a function, or others. They can start with a letter from capital A to Z, small letter a to Z, or an underscore, and can be followed by 0 or more letters, underscores, and digits. Punctuations and characters are not allowed. Please note that identifiers are case sensitive. You will get an error if you're using an identifier that is not defined. There are some keywords that are reserved in C because they serve a special purpose. Examples of these are else, enum, long, switch, typedef, sizeof, char, and others. You will notice this because Arduino will change the color or highlights them in another color. White spaces separate one part of a statement from another. It identifies where one element of a statement ends and where the next element begins. Arduino or C actually treats different kinds of spaces as the same. For example, it treats blanks, tabs, new line characters, and comments as a white space. So it's okay if you have a lot of white spaces. Arduino or C will treat it the same. Variables are a type of identifier that can take up a value. They are names given to a storage area that programs can manipulate. Each variable has a specific data type. which determines the size and layout of the variable's memory. Let's have here some data types that variables can take. Char data type. Char data type is typically a single octet or 1 byte. 1 byte means you have 8 bits of data. Char is usually used in storing a single character, like for example, the character of letter A. The int data type is the most natural size of integer for the machine. Integer usually takes of 8 bits of data and is usually used for natural counting numbers like 1, 2, 100, 1054, and others. Float. Float data type is a single precision floating point value. It is used for numbers that use a decimal place. For example, numbers like 3.14 or 1.6489 as long as there's a decimal point. Double is a double precision floating point value. A double is essentially a float that has more precision or can hold more decimal places. You can use this, for example, when defining a GPS location which has a very long decimal point value. And then there's void data type. Void represents the absence of a type. So in C, if you have no type, then it's void. The char data type is used to store a single character. It's also used to represent characters using ASCII encoding. You can Google ASCII encoding and see that each character in the alphabet is equivalent to an 8-bit value. How do we define character values? Just use char and then the identifier or variable equals the value which is in single quote like this. Char is the data type, A is the variable, and then B in single quotes is the value. Therefore, the variable A has a value B. B is encoded with its ASCII equivalent, and the resulting value, which is 66, is stored in the variable A. Now, what does A plus exclamation point equal? A variable can contain a single value, but a variable can also contain multiple values. This variable is called an array. You will know that it is an array because it has an index, indicated by square brackets. The index identifies the number of elements or values that the array contains. For example, if it has 3 as index, it means that it has 3 values. Arrays are zero index, meaning they start at 0 and end with the number -1. For example, I have here an integer array called 3ints. 3ints has 3 elements inside it. If I want to access each element, then I will index each element from 0 to 2. So the first element is 3ints square brackets 0, the second element is 3ints square brackets 1, and the third element is 3ints square bracket 2. So if 3ints 0 is 15 and 3ints 1 is 10, then 3ints 2 is equal to 3ints 0 minus 3ints 1 is what? The value is 5. We just use the values 15 minus 10 equals 5. You can also use an array with other data types, like for example, for a float, for a char, for a double. Now, an array of characters is called a string, small letter s. For example, char example string index 8, and then example string equals Arduino. Note that for a string, we use double quotes. Compared to a char, we use single quote. The last element of a string is always the null string, which has an ASCII value of 0, meaning it is null terminated or it always has a 0 value at the end. Don't confuse this with the big letter S string. The big letter S string is actually a class. For the string class, you can actually store the string as an object. The capital S string uses string objects rather than character arrays and uses more memory but adds more functionality. So when do we use the capital S string? We use this if we want to manipulate text strings, like we want to copy certain parts of the string and then change or edit it into something else. because it's difficult to do that with the character array string. How do we define a variable? We define a variable by simply stating the data type, space, and then the variable name, then semicolon. You can also define multiple variables in a single line, like data type, space, first variable, comma, space, second variable, comma, space, third variable, so on and so forth, and semicolon. For example, int I, comma, j, comma, k, semicolon. This means that I, j, and k are all integers. Char c, comma, ch, semicolon, means that both c and ch are char. Float f, comma, salary, semicolon, means f and salary are floats. Double d means d is a double. We can also declare variables and initialize them immediately on a single line. Initialization means we give an initial value to the variable. Example, int d equals 3, comma f equals 5, means that d is an integer with initial value 3 and f is an integer with initial value 5. Char x equals quote x, quote, semicolon. It means that x is a variable with data type char and initial value x. What is a function? A function is a building block of the C programming language. It is a group of statements that together perform a task. Every C program has at least one function, which is the main function. In Arduino, we should have at least these two functions, void setup and void loop. Void setup function is executed once only at the beginning of code execution. We put here all our initialization codes and setup codes. The loop function, on the other hand, is executed indefinitely and will repeat forever as long as there is power. We put here your main code. A function definition provides the actual body of the function. Let's see an example of a function definition. The syntax is return type, space, function name, open parenthesis, the parameter list, close parenthesis. And then we have the open curly brace, and inside the body of the function. The body is just statements or expressions. Then finally, we have a close curly brace. Please don't forget the open and close curly brace, as you will get an error if you haven't enclosed the statements within these curly braces. Let's have an example for a function definition. Based on our syntax, we have int max, int num1, comma, int num2, where int is our return type, max is our variable name, int num1 and int num2 are our parameters. Notice that for parameters, we also include the data types. Num1 has int data type, num2 has int data type. Then we have the open and close curly braces. And inside that is our body, which are just statements or expressions. Now in the body, we have a comment, local variable declaration. So it's not included in the code, it's just a comment. And then we define result as an integer. And then we have an if-else statement. So we will discuss if-else statement in a bit. Then finally, we have return result. Notice that for a function, you usually want to return a value. In this case, it returns result, which is an integer. This is the reason why we need to indicate the return type at the top of our function definition. In this case, the return type is int. If you don't want to return any value, then you can use the data type void. Like for example, void max. That was defining a function. But how do we use a function? We can use it by just calling it in our code. When a program calls a function, the program control is transferred to the called function, meaning it jumps from its current line to the function. To call a function, you simply need to pass the required parameters along with the function name. Let's have an example for calling a function. I have here two functions. The one on the left is the main function. The one on the right is the max function. Max, this is the same function we have defined before. Return type is int. Parameters are num1 and num2. Both are ints. So on the main function, we've declared variable a as an integer with initial value 100. b as an integer with initial value 200, and ret as an integer. Ret will store the returned value. This is how we call a function. We just call the function name, which is max, and then include the parameters in the parameter list, which are a and b. So when you call max, the code execution will go or jump here, and then a will be passed to num1, b will be passed to num2. Now num1 has a value of 100 and num2 has a value of 200. Now int result, and then we have an if-else statement. If num1 is greater than num2, then result is equal to num1. Since num1 is 100 and num2 is 200, this condition is false because 100 is not greater than 200. The code execution will go to else. It will skip the if. So else result is equal to num2. It means that the value of result is 200. And then return result. Notice that result is an integer, which is actually correct because we have a return type of int. So return result means return 200, meaning the value of max a comma b is 200 and ret equals 200. Arduino libraries. For beginners, Arduino libraries are a great tool to help speed up the development process when using specific modules and kits. Arduino libraries provide functions that you can just use out of the box and call those functions in order to implement specific operations for those modules. The libraries provide extra functionality for use in your sketch, like working with hardware or manipulating data. Arduino has provided a lot of libraries in its website. Here, you can use libraries for reading and writing to EEPROM, to connecting to the internet using LAN or Ethernet, connecting to a GSM or GPRS network if you want to send text or SMS or call, liquid crystal display, SD card, servo motor, if you want SPI communications, if you want to have software serial, controlling a stepper motor, TFT display, Wi-Fi, and wire for I2C communications. There are also third-party libraries which are developed by third-party developers. Usually, these third-party libraries are shared in GitHub. For example, this is an Adafruit library for a DHT sensor. So what you can see in the library are two main files. You have the .cpp file, which is the C++ file, and the .h file. The .cpp file contains the functions that you can use when you use this library. The .h file contains the header files, and .h is the one that we include in our code. What is a header file? A header file is a file with extension .h. It contains C function declarations and macro definitions to be shared with several source files. It is very common that if you're using a library, then you will use its header file. To use a header file in your program, just use the hashtag or number sign include. For system header files, we can write number include and the file name enclosed in angle brackets. For user or custom header files, we can write number include the file name enclosed in double quotes. Actually, these are interchangeable. This is just the convention. What is a preprocessor? A preprocessor is not part of the compiler, but it is a separate step in the compilation process. It instructs the compiler to do required pre-processing before the actual compilation, meaning it will do that line first before it gets to be compiled. All preprocessor commands begin with a hash symbol or number sign. Here are some examples of preprocessors. Number define. Number define substitutes a preprocessor macro. It means that we can define a variable or a macro using number define. For example, number define space max array length space 20. It means that the variable max array length has a value 20. Number include. This inserts a particular header from another file. This is the one I discussed earlier. If we include a header file in our code, it means that we're including the whole library. There are several more preprocessor directives like number undef, number def, number if, number else, number elif, and many more. Decision making and loops. Much of our Arduino code will contain logic or conditionals that determine what happens if a certain condition is met or not. So first we discuss about decision making. In this lesson, we will discuss the if statement, if-else statement, nested if statement, switch statement, and nested switch statement. But before that, it is important to note that the C programming language assumes any non-zero and non-values as true. Meaning if it's non-zero, it is true, and 0 is false. Let's start with the if statement. The logic flow is like this. The condition will be checked. If it's true, then it will do the conditional code. If it's false, it will just exit. Let's have an example. I have here a main function. Variable a is declared as an integer with initial value is 10. And then I have an if statement. If open and close parentheses, and then the condition is inside the parentheses. The condition is a is less than 20. Then you have the open and close curly braces, and inside that is your condition body. So if a is less than 20, check this if this is true. If this is true, then do this. If this is false, if this is false, then exit. Go directly here to printf. So let's see. Is a less than 20? The value of a is 10. So 10 is less than 20. So we will execute this part. This is a comment. And then this is printf. A is less than 20/n. It will print in the screen a is less than 20/n means new line. Then after that, it will print value of a is %d/n, comma a. %d here is a format specifier for decimal. And then a here replaces %t, such that this will print value of a is a, which is 10. Return 0. Next is the if-else statement. It's similar to the if statement. The only difference is that if the condition is true, it will do the if code. If it's false, then it will do the else code and then exit. Now, there's the presence of the else code when the condition is false. Unlike the previous one, it will just exit. Let's have an example. This is a main function with variable a as integer, initial value 100. Then, here's the if-else statement. If a is less than 20, then open and close curly braces. This is the body of the if. And then else, and then we have the open and close curly braces. This is the body of the else code. Now, let's evaluate. Is a less than 20? Value of a is 100. So 100 is not less than 20. So meaning this is false. Since this one is false, it will not do this code. What it will do is it will go to the else code. So it will execute this part. Printf, a is not less than 20/n. And then after that, it will go to printf, value of a is %d/n, a. Again, %d is a format specifier for decimal value. And a here will replace %d. So value of a is 100. Return 0. Next, if-else if. If you have multiple conditions, you can use if-else if. This is how it's written. If Boolean expression 1 is true, then do this. Else if another expression here. If this is true, do this. Else if you have a third expression here, if this is true, do this. Else, if all above statements are false, then do the else code here. Nested if statement. Nested if statement is when we have a smaller if statement inside a bigger if statement. So here's an example. A is 100, B is 200. And then here is the outer if statement. If A is equal to 100, open curly brace, close curly brace. Then we have another if statement inside. If B is equal to 200, open curly brace of the inner if statement, close curly brace of the inner if statement. Since this is true, and since this one is also true, then it will print the value of A is 100 and B is 200. Now, what does this double equal sign mean? Double equal sign means comparison. It compares if A is equal to 100. It is different with the single equal sign. Single equal sign is assignment, meaning it assigns 200 as value of B. Switch statement. Switch statement is similar in concept to if-else if statement, but it has a different syntax. Now, evaluate the expression. If it satisfies case 1, do code block 1. If it satisfies case 2, do code block 2. And so on and so forth. Then default. If all the cases are not true, then go to default. Do code block N. Exit. Let's see how it's used in an example. I have here a main function. Grade is a char with initial value of B. And then here's the switch statement. Notice the syntax switch and then the variable inside the parentheses. And then you have open and close curly brace, the start and end of the switch statement. And then you have the case statements. Case A, case B, case C, case D, case F, and default. Each case presents an option value for grade variable, meaning grade here can be A, can be B, C, so on and so forth. So if grade is A, it will do this. If grade is B, it will do this. If grade is C, it will do this, and so on and so forth. Note that in the switch case statement, in each case, there is a break statement before each case statement ends. This is important because if the program does not see a break statement, it will consider the codes below it as part of that case statement. Let's see. So the value of grade is B. In this code, we're expecting that switch grade, it will go to case B. So it will go here. And then it doesn't have anything from it. Doesn't have break statement. So it will assume that this next line is still part of case B. So it will go to case C, printf well done, break. Meaning, well done will be printed, break ends the switch statement, so it will go directly out here, outside the switch statement. Your grade is %c/n grade. Again, %c is a format specifier for character, and grade is a character, so your grade is B. Nested switch statement. A nested switch statement is if you have a switch statement inside a bigger switch statement. You can see here, switch B is inside switch A. Also, notice that we're using indentation so that we can clearly see which one is part of the other. Because if we do not indent this, it's very difficult to identify which one is part of the other. Here you can easily see that printf is part of case 200, and then case 200 is part of switch B. And then switch B is actually on same level with printf, and both of them, printf and switch B, is inside case 100. And then case 100 is inside switch A. Now, let's go to loops. In our Arduino code, there will come a time that our code will be repetitive, meaning we will do the same task again and again. So instead of writing the code as is, we just use loops to help us shorten our code. Examples of loops are while loop, for loop, do while loop, and nested loops. For while loop, this is the syntax. While, open and close parentheses, and the condition inside, open and close curly brace, and then the conditional code inside. When condition is true, it will do the code block. As long as it is true, it will do the code block. So it will just repeat as long as it's true. When the condition becomes false, then it will exit and go to the next line of code. Here's an example. A is an integer variable with value 10. And then we have the while statement, while a is less than 20. Meaning, if as long as a is less than 20, do this. If a is not less than 20 anymore, then exit and go to return 0. Let's check. Initial value of a is 10. Is 10 less than 20? True. So it will print value of a is 10. Then a++ here is similar to a equals a plus 1, meaning it will increment with a value of 1. So the value of a is now 11. Then it will return here. It will check if 11 is less than 20. Yes. So value of a 11. A++. Value of a becomes 12. Check again. 12 is less than 20. Yes. Print value of a is 12. A++. A is now 13. Go back again. So on and so forth until we reach 19. So for example, the value of a is now 19. Is a less than 20? Yes. So it's still true. Print f, value of a 19. A++, then the value of a becomes 20. Then we return here. Is 20 less than 20? False. So this condition is false. So it will exit this and go here. Return 0. For loop. For loop, the syntax is like this. For, open and close parentheses, and you have 3 parameters separated by semicolons. First parameter is init or initialization. Second parameter is condition. This is the condition that will be checked if it is true or false. And then the increment, or this can also be a decrement. And then open and close curly braces and your conditional code inside. Now, initialize and then check condition. If it's true, do the code block. And then after that, increment or decrement. And then go back to check the condition. If it's true, do these 2 blocks again until it becomes false, then exit. Now, this is a similar operation as the previous example, but the implementation is using a for loop. So I have here for. This is the initialization in a equals to 10. This is the condition. A is less than 20. So if as long as a is less than 20, repeat this. If it's not anymore less than 20, exit. And then the increment is a equals a plus 1. You can also write here a plus plus. So let's see. Initial value of a is 10. 10 is less than 20. True. Then execute this. Value of a is 10. And then increment. 10 plus 1 is 11. Repeat. Is 11 less than 20? Yes. Print. Value of a 11. Increment. A becomes 12. 12 less than 20? Yes. So on and so forth until we reach 19. Is 19 less than 20? Yes. Print value of a 19. 19 plus 1, 20. Is 20 less than 20? No. False. So we exit and we go to return 0. Do while loop. The do while loop is similar to the while loop. The only difference is that the while condition is at the last part. So meaning, do, open and close curly braces, and then the conditional code, and then the while statement is at the end. Do the conditional code first and check the condition later. Like this, code block, and then check condition. If true, do code block again. As long as this is true, it will repeat. If it's false, then exit. Here's an example. Do, open and close curly brace, the code block. So print value of A is 10, and then A becomes 11. And then while 11 is less than 20, true, repeat, value of A 11, A becomes 12, 12 less than 20, true, repeat, so on and so forth until we reach 19. Value of A is 19, 19 plus 1 is 20, is 20 less than 20, false, so this becomes false and we will exit, return 0. Nested loop, it just means that you have a loop inside a loop. So you see here, this is a for loop, a smaller for loop. It iterates itself in the j variable. So for j is equal to 2, j is less than or equal to I divided by j, j plus plus. And then this small for loop is inside the outer for loop, which is for I is equal to 2, I is less than 100, I plus plus. It's interesting to note that this kind of code is used in processing rows and columns. For example, J can be for rows and then I can be for columns, so that all the data in the spreadsheet or table can be processed. Now let's learn about basic tools and functions that we often use in Arduino. Note that I will be discussing only a few, since you will encounter more along the way on the next modules. So first is the serial monitor. This is an important tool that we can use in order to check what's happening in our code. So we can print out messages here such that we know what is the output, for example, of a sensor reading or the input from a specific pin. So to use the serial monitor, make sure that your Arduino is already connected to your laptop via the USB cable. So check first Tools, and Board, Arduino Genuino Uno. Tools, Port, make sure you have selected the correct COM port. In my case, it's COM4. And then on the upper right, there's this magnifying glass icon, serial monitor. Just click it. And then a new window will come out. So here, if you have in your sketch printed out messages, then it will print out here. You will see them here. Just some notes. This is the baud rate. You can change the baud rate settings here. The default is 9600 baud, but you can increase it, let's say 115200, or decrease it, depending on your application. This one is when you need a new line or a carriage return. If you don't need a new line, so no line ending. If you have too many stuff going on here already, just you can clear output, so everything will clear again and start receiving new serial messages. So in essence, the serial monitor is a very good tool to monitor what's going on in our sketch, what's going on in the operation of our codes. Here are the usual functions we use using the serial monitor. Serial.begin, this is to enable or start the serial monitor. The number here is the baud rate or the speed of communications between your laptop and Arduino. So 9600 bits per second. Two main functions used to print out messages are serial.print and serial.println. Inside it, the parameter is the message. You put double quotes if it's a text string message. You do not put double quotes if it's a variable or an identifier. The difference between print and println is that the ln here means new line, so it will introduce a new line or enter after printing out the message. Other functions used for serial monitor is serial.read if you want to read the first byte from a memory buffer, serial.available, which returns a number of bytes in the buffer, meaning the number of bytes available in the memory, and serial.flush to clear out the buffer. When I say buffer, it means memory unit in the serial port. Digital output. So the digital output pins of the Arduino can output a high, which is 5 volts, or low, which is 0 volts. Before you can use the digital output, you need to set pin mode in the setup function. Example, pin mode and then parameters are the pin, which is pin 13, and then output. In the loop, we use the function digital write to set pin 13 to high. So the parameters for digital write are the pin number and the state, which is either high or low. High means it will output a 5 volts. Low means it will output 0 volts. Delay here is to introduce a delay in milliseconds. So we have here 1000. It means 1000 milliseconds is equal to 1 second. So the output we are expecting here is that since here it stated that pin 13 is connected to a light emitting diode or LED, our LED will light and then it will wait for 1 second and then it will turn off and then wait for another 1 second. Digital input. So the Arduino pins can also read if the input pin is either a high or a low. If the pin has 2.7 volts to 5 volts, then it will read it as a high. If the pin has 1.2 volts to 0 volts, then it is a low. Same as the digital write, you need to set the pin mode in the setup function. So here, we introduce this part, pin mode, in pin, and then comma, input. Notice now that we have two pin modes. The first one is for the LED pin, which is output, since we are going to set the value of the pin, LED pin. The next pin mode, in pin, is input, since we're going to read the value on the pin. Notice the difference. Pin mode, output, is to set the value of the pin. Pin mode, input, is to read the value of that pin. Now, the function that we're going to use is digital read. And then the parameter is the pin or the pin number. Val here is equal to digital read in pin. Now we have two functions, digital read and digital write. Analog input. We have already discussed the difference between analog and digital signals. Analog inputs allow us to read analog voltage signals, but first we have to discretize them. Fortunately, Arduino has a built-in analog to digital converter which does the discretization or converting from analog to digital. The Uno has a 10-bit analog to digital converter. The formula is 2 raised to 10, that's 1024. It means that we have 1024 digital discrete levels. So the analog voltage from 0 to 5 volts will now be scaled to integers between 0 to 1023. 0 as the very first value and 1023 as the last value. That's 1024 points or values all in all. Now the function we use for analog input is analog read with one parameter which is the pin. Note that the pin should be an analog pin. Analog output. The Arduino has no true analog output, but we can simulate an analog output using what we call pulse width modulation or PWM. So there are only specific pins in the Arduino that can do pulse width modulation. The concept of pulse width modulation is that we introduce train of pulses that rapidly turns on and off. A duty cycle of the pulse can be adjusted, which controls the average power output of the pin. For example, I have here a pulse between 5 volts and 0 volts. When we say we have a 25% duty cycle, it means that 25% of the time it's on or high, meaning 25% of the time it's 5 volts. 75% of the time it's low or it's 0 volts. For 50% duty cycle, 50% of the time it's high, 50% of the time it's low. For 75% duty cycle, 75% of the time it's high, 25% of the time it's low. For 100%, it's high all the time. For 0%, it's low all the time. So the function we use for analog output is analog write. It takes two parameters, the pin number and the value, which is a number between 0 to 255. Why is that? because the PWM output of the Arduino is 8 bits only. So our formula, 2 raised to 8 equals 256. So we can have a value between 0 to 255. Pulse-width modulation is very useful in light dimming, wherein we want to fade in and fade out light, or fade in and fade out a sound, or control the speed of a motor. That's it for this lesson. In the next modules, you will use your Arduino sensor kit base and the bonus modules to do some really exciting hands-on activities.